Good morning, Geometry Honor students. So it's Mr. Chen again. So today we want to talk about the lesson for 2.5. So this one, it's about proving statements about segments and angles. Okay, so this one, instead of using the flow chart for the proof, we're using the two-column proof. So basically, mainly, we just want to focus on the two-column proof. I know some of the examples shows you like the flow chart. Usually the flow chart is a little bit kind of confusing, because that it has so many arrow pointing to like certain positions or the blank. Okay, so now to look at that, this one's like a flow chart. Okay, so given with the statement, so AC equals AB plus AB. Okay, so this one obviously using that the segment addition postulates. So you started off with the given. Okay, so this one is the given. Okay, so started with the given statement, which is what, B right here. And then this one, the next one, it shows that AB plus BC equals AC. As you can see the diagram here, AB plus BC, so this one that involved with the segment additions postulates. So segment addition postulates. So post 1.2 from section 1.2, so this one is A. And then another thing that we notice, AB plus AB is the same as AB plus BC. So basically what this one is saying that from step 1 and step 2, once you combine those two things together, so this one would be considered the transitive properties of equality. So anytime I see that it has three elements involved, AB, BC, and what else? And AC all together. So this one is considered all three elements involved. Okay? So eventually, by subtracting AB on both sides, so we do have AB equals BC. So using the subtraction properties of equality. Okay? So now, let's see what else that we have for the other one. So this one similar. So measure of angle 1 is the same as measure of angle 3. So they're equal. So it's given. So start with given, which is E right here for the selection. And then the measure of angle EBA equals measure of angle 2 plus the measure of angle 3. So 2 and 3. So this one will be considered angle addition postulate. So for this one, you can choose either A or D, doesn't matter. So I will use A here. And then EBA, it's the measure of angle 2 and 1. So also it's considered angle addition postulate. So this one will be D. And then EBA is the same as measure of angle 1 plus measure of angle 2. So as you can see that here, EBA, it's exact same measurements with the angle. So this one can be written as, okay, angle 1 plus angle 2. Okay, so this one, it looks like it's the exact same thing as what we got for the previous one. Okay, so this one, you just say that it's just the substitution property. Okay, substitution property. And then measure of angle 1 plus measure of angle 2 equals angle CBD. Okay, so CBD. You know what? This one is actually considered. Okay, so for D, it's supposed to be transitive property. Excuse me. So let's fix that. Because this one is being replaced that by angle 2 plus angle 1. So this one is a transitive property. So for B. And then C, it just considered that the angle 1 plus angle 2, so we swap the addition. So this one will be considered commutative properties of addition. Okay, excuse me. Just fix that. And then another thing that we notice, angle 1 plus angle 2, combine them together, so that forms angle CBD. So that's another angle addition postulate. And then finally, the measure of angle EBA is the same as measure of CBD. Okay, so you're showing that they're equal. So this one, I would say that it's the, okay, so the last one that's remain is substitution property. Okay, so then that'd be C. Alright, okay, so now let's see what else that we have for the proof. Right angle congruent theorem, or right angles are congruent, always true. Okay, so here's another example. You guys can take a look at that. Statements and reason with the flow chart. let's see, another one. So AB is perpendicular to segment BC, okay? And segment DC is perpendicular to segment BC. Definition of perpendicular line, so this way you can say that segments, well, definition of perpendicular line, so this one, it forms 90-degree angle. So angle you can say that angle B equals 90 degree, same as that angle C, which is forms 90 degree perpendicularity. And then angle B is congruent to angle C. This one is by definition of right angle. Okay, so now let's see what else. Congruent Supplements Theorem. So this one, again, if angle 1 and angle 2 are supplementary, angle 3 and angle 2 are supplementary, so therefore angle 1 is congruent to angle 3. And the other one is similar, Congruent Complements Theorem. So if angle 4 and angle 5 are complementary, angle 6, angle 5 are complementary, so therefore angle 4 is congruent to angle 6. Okay, so here's one of the example. So showing that supplementary, showing that it's 180 degree, definition of supplementary angle. So therefore, measure of angle 1 plus measure of angle 2, it's the same as measure of angle 3 plus measure of angle 2. Transitive properties of equality, and therefore subtract angle 2 both sides. So we got angle 1 is the same as angle 3. Subtraction properties of equality, so therefore angle 1 is congruent to angle 3. Definition of congruent angles. So linear pair postulates, so angle 1, angle 2 form linear pair, or just a straight line or straight angles. So therefore angle 1, angle 2 are supplementary, or measure of angle 1 plus measure of angle 2 is 180 degree. Vertical angles, so angle facing to each other, so the cross angle, so 2 and 4, they are congruent, 1 and 3, okay. We are not doing the paragraph proof, so no need to worry about that. So here's another one, fill in the blank. So given that AB is the same as DE, BC is the same as CD, so AB plus BC is the same as BC plus DE. Addition properties of equality. And then the other one, subtraction properties of equality, excuse me. So subtract BC both sides, so we do have AB equals DE. Okay, so this one showing that AB plus BC equals AC. Okay, so that would be the segment addition postulate. So I'll just abbreviate that. Subtraction properties of equality. So this one, so after that you subtract, let's see. So things that they share in common. So eventually we want to show that AC is congruent to CE. Okay, so basically this one we can just subtract BC on both sides. Oh, substitution properties of equality. So we just say that AC is it's equal to CE. And then the last piece right there, so segments congruent, or definition of segments of congruency. Because at this one, since we're showing they're exactly the same, so that means those two segments got to be congruent to each other. Okay, so now let's see what else that we got right here. Okay, rewrite two-column proof in example 3, so definitely you can just go back to it. Step 1, step 2, the reason with the statements. So find the value of x. So one thing that we notice, angle TPS, which is congruent to angle QPR. Okay, QPR. And the reason for that is because this one is what? Vertical angle? Definition of vertical angles. So therefore that TPS 148, it's the same as 3x plus 1. This one is very straightforward. Subtract 1 both sides, so we got 147 equals 3x. Divided by 3, so 4 times 3 is 12, 27, so 49. So x equals 49. It's just a variable, there's no need to put in a unit. So here's more example finding the vertical angle. If angle 1 is 117, what's the measure of the rest of the angle? So angle 2, then that'll be what? 180 minus 117. Linear pair, find out exactly what that is. Angle 4 is the same as angle 2. Angle 1 is the same as angle 3. So angle 3, it's also what? 117. Again, it's pretty straightforward. This one is just an extra practice, like the previous problem we were talking about. So here's the proof. So let's do the, instead of doing the paragraph proof, let's do the 2-column proof. So statement and reason. So started off with that given. So angle 1 is congruent to angle 4. Okay, so that's given. And other thing that we notice here, angle 1 is the same as angle 2, which is using the same definition of vertical angle. So angle 3 is the same as what? Angle 4, congruent. So definition of vertical angles. So since we do know that they're exactly the same, so what we can put in here, so angle 2 will be the same as what? Angle 3. This one is by transitive property. Again, anything that has more than 3 elements, so that'll be transitive property. Okay, so let's see what else. Okay, so here's another one. So we'll do the 2-column proof once again. So statement and reason. So angle 1, it's a right angle. Okay, so that one's a right angle. Given. So if that's a right angle, so that means, well, according to the diagram, things that you see right here, so angle 1, it's what? 90 degrees. Definition of a right angle. And then after that, so you can say that angle 1 plus angle 2 equals 180 degree. This one can say that's linear pair or supplementary angle. And then the next step here, so in order to get the measure of angle 2, so angle 2 equals 90 degree. So this one, subtract 90 on both sides, so this one will be subtractions, angle subtractions postulate. And then the last statement, since we do know that angle 2 is 90 degree, so angle 2 is a right angle. So this one, just say that definition of a right angle. Alright, okay, so now let's see what else. So here's more proof, finding that the statements, reasons with that angle 1 congruent to angle 2. You want to show that angle 2 is the same as angle 1. Given definition of congruent angle, symmetric properties, so you can swap them, and then using that definition of congruent angle again. Okay, so pretty basic. Okay, so making sure that you just refresh with what you just did. Okay, so things that we talk about in this video. So things that you want to go back, please rewind it, or just, fast forward to the part of the area that you're having difficulty with. Okay, so thank you for watching it. Again, please subscribe to the channel. So I'll see you guys next time. Have a great one.